These are the homework solutions for chapter 4.1. We'll start with problems 9 through 9, 10, and 11 and 12. Those are short answer questions. Determine whether the scatter diagram indicates a linear relationship may exist between two variables. So as we talked in class, to answer those questions, I showed you some examples, and we're looking for patterns within the explanatory and response variable. And so for number 9, I think there is a pattern. You can see it kind of shaped that way. And so I would say this is non-linear, right? That doesn't indicate a linear pattern, positive or negative association. The relation, it's non-linear. Here I would see we have a linear association. So a linear association, and I would even say this is negative. So we're looking for there. That's 9 and 10. For 11 and 12, again, I see a linear relationship forming a line, and this will connect back to our algebra class where y equals mx plus b and the meaning of those. So I think this is a linear association, and what we have is a positive relationship. And again, this one's a little bit more scattered, and so I would say this is definitely non-linear or no pattern at all. A non-linear, or you might even say no association, but we would have to use statistics to determine that. And again, where am I getting that language from? It comes from our notes in class. Comes from our the notes we took. Maybe not there. We had these conversations of shapes from your notes. You could refer to your notes to see the different things that we have here. No linear, non-linear. We also talked about this here, no relation. So that's where it's coming from. And it's positive again as the, it's a positive association when as the x values increase, the y values increase. Negative association when the x values increase, the y values decrease. And so that's what we're talking about. Now move on to problem number 13. Problem number 13 from chapter 4.1 homework. And in this case here, what we're trying to do is match the correlation coefficient. So we talked in class about correlation coefficients. Now, if there is a relationship as we have here, we want to calculate its relationship. And so one way we do that is through the linear correlation coefficient. We use StatCrunch to do that, which we will do, I think, on another problem, down here. So looking at that correlation, match the linear correlation coefficient. So it goes back to our notes. Let's go back there one more time. In your notes in 4.1, we kind of gave you some example here where the correlation coefficient is kind of like a way of ranking whether we have a linear relationship. And we ranked, instead of saying rank from 0 to 10, the way we rank is a value between -1 and 1. So that's how it gets ranked. The more perfect positive line, r equals 1. The correlation is 1. A more the perfect negative relationship, r equals -1. Then you have everything in between. If it's positive, you see values 0.9, 0.4, and we did that in class when we played Guess My Correlation game, trying to guess that. So that's all we're looking at. And so in this case here, looking at these problems here, I think the most obvious one, the obvious relationship I think that we have here would be, I think, let's go with D. I think D is an easy one to match up with because it's the closest to 1. And so I think that would match up with graph number 1 here. That's a nice, almost perfect. The next one is, I think, the smallest one. We go with this one here. And the one that has the least amount of kind of correlation, I think, is more like this one here. And so we would say that this one goes with graph 2. And then we had left with graph 3 and 4. And I think this one has a little bit more correlation than this one here. There's a little bit more points outside. And so we would conclude that graph 3 goes with A, and then graph 4 goes here. And again, it has to do with, these are all positives. This one's a little bit less correlated, and those are ranking systems, basically, of how much correlation we have. And those are positive because these are positive graphs, or they're positive associations. Let's go ahead and move to problem number 14 from chapter 4.1. And so looking at this, the same work, just now we have negative associations. So notice the R values are negative. So this one's obvious. This is a perfect one. So graph 1 would go with C. Now I'm looking for the weakest one. This one would be the weakest one. It's kind of mixed up. So its R value is going to be very small or close to 0. And so B goes with 3. The next hard ones are these. These are very close values. And so I think just on this one, I think this one's a little bit tighter. And so you can see just less air there. And so I would say this goes with graph 2, and this one would go with graph 4 would go there. And so I think that's the relationship we're looking at. Again, make sure go back to your notes to refer to how we did that. So we move on to problem number 16 from chapter 4.1. And so what we have here is the following scatter diagram drawn in Stackern shows the relationship between percent of the population with at least a bachelor's degree in a state and the birth rate, births per 1,000 women who are 15 to 44. So we're looking at, basically there's a question of the if women have more degrees in a state, do they have, what's the relationship to birth rate? And so just on observation, looking at it, the first question, A, does there appear to be any relationship? I think this is a tough one. There might be a slight, I think that there's a slight, and I'm just using that word, slight or weak. You might use weak. I think negative association, but I don't. It's hard to really distinguish. It looks like there's some, as there's more college degrees, there's less birth rate, but I would say that's weak relationship. And I do think, actually, make a note here as I read this problem, I think this is a typo. Actually, this should say should say percent with a bachelor's degree. So I think that this variable should say that there. And I think there is correlation between your income and bachelor's degree too. So there could be that there. And so be careful here. I think these are typos here. I think that should say bachelor's degree. And then on B, as we look at solution for B, slight negative association between them, I would say, or some might argue no association. Part B, the correlation between percent population with at least a bachelor's degree and birth rate is negative. So what they're saying now is R equals negative 0.069. So that definitely matches up to our thought there, slight negative. What does this imply about the relationship between those variables? Again, I think that because the R value is so small, I think because the R value is small or close to 0, I might want to say there is no linear relation or association. So I think we can probably conclude that we would need to do more statistical tests to do that. And that's what we're going to do in the next problem, where we compare this value to the critical value. That's what we'd have to do. Okay, move on to problem number 29 from chapter 4.1. And so I'm going to have StatCrunch enter this data in. Questions we're asking: determine which variable is explanatory response in this. And the situation involved here is, do weights of cars influence the miles per gallon the car gets? And so that's the question. And so we'll see if there's a relationship between that. And so I think before we go to StatCrunch, you can answer that question. I think in this case, for part A, I think the explanatory variable, I think the explanatory variable is the weight of a car. I think that's the explanatory variable. B, we're going to go ahead and draw a scatter diagram. Oh, and let's finish this. The explanatory, then the response variable. The response variable would be the miles per gallon, your MPG, how many miles you get. So let's go ahead and graph this in StatCrunch to take a look at what we get here. And then we'll get our values here. And so we're going to go ahead and make a scatter diagram. But the way we're going to do it is through a regression. We're going to do a regression analysis here. That's going to help us calculate the regression coefficient. Remember, we're not going to do this by hand. If you look at examples, they're in there. They do it by hand. And so let's go ahead. That's all you got to do. Put the right variables and explanatory and response variables. Hit compute. And so you get some information that's worth recording down here. And so what we're looking at right here, and then here's the scatter diagram. There's the graph. And so from that graph, if we look carefully, it does look like we have some negative relationship, meaning that as the weight increases, it does look like that we have a decrease in miles per gallon. And so in this case here, we then can answer. So there's our scatter diagram. And so there's what it looks like. And again, from there, make sure you can identify the negative association. Okay, so now that we have the scatter diagram, we see the relationship. We could answer step C, compute the linear correlation coefficient between the weight of car. So that has been computed in StatCrunch. That appears right here. So there's the correlation coefficient. And so then we have that value to make sure we can, so there's our correlation coefficient, negative, it's close to 1. So we've done that. Does a linear relation exist between the weight of a car and the miles per gallon in the city? So we're looking to see if this is an actual relationship. We have to formally then remember. Let's go back to your notes real quick to take a look what I'm talking about here. To determine that, we have to go back and compare to the critical values. And so we can't 100% say for sure we have a relationship until we compare that correlation coefficient with, is there association or relationship or correlation, until we compare it here. So we go back to this problem here and we look to see if, and so we're going to compare the value that we got here, this correlation. We notice we had how many data points, the sample size. And so from here to answer D, we need to know the sample size. The sample size in this case equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sample size is 10. And then we have a critical value. The critical value for sample size of 10 is, coming back here, 10 is 0.632. That's the critical value. And what we're doing is trying to actually determine if we have it, 0.632. And the rule is if the absolute value of your correlation coefficient is greater than the critical value, we have an association. We have a linear association, or correlation is another word we can say. And so the answer is yes, since 0.842 is greater than 0.632. We have officially, statistically, we can say we have linear association or linear correlation.